Okay, guys, in this video, we're going to go over how to use factoring and trig identities to rewrite some of these trig expressions. So we're going to go over these three examples here. The first, sine x times cos squared x minus sine of x. All right, so looking at this expression, okay, you might be able to see that this is basically going to be like a GCF factoring problem. And the GCF, for example, one is sine of x. So if you factor out a sine of x from both of these terms here, you're going to be left with cos squared x minus 1. And inside this parentheses here, this should look pretty familiar. It looks like a version of the Pythagorean identity. So the version of the Pythagorean identity that it looks like is 1 minus cos squared x. So here we have cos squared x minus 1. So it's just the opposite sign. So if 1 minus cos squared x here is equal to positive sine squared x, if we change this 1 to a negative 1, and then we change this negative cos squared to positive cos squared, all right, we essentially have this term here. Then this becomes negative sine squared. Forgot to put a 2 there. So it should be negative sine squared x. So what we're going to do is we're going to replace this cos squared x minus 1 with negative sine squared x. So it becomes sine x times negative sine squared x. And we can essentially just end up multiplying sine x times negative sine squared to give us negative sine cubed, negative sine of x cubed. You can write it like this, or you could also technically write it as sine of x, negative sine of x quantity cubed, like that. Actually, I should probably put the negative sign outside here. Yeah, because PEMDAS would be exponents and then multiply by the negative value here after. So that would be our two kind of final answers that we would have. So we had to factor with a GCF as well as use the Pythagorean identity, a little bit of a rewrite with the Pythagorean identity to simplify it. So example 2 here, we have 4 tan squared theta plus tan theta minus 3. And this looks kind of like a quadratic expression where we would have to factor. And that's exactly what it is. So let's say that this is similar to 4x squared plus, instead of tangent, we could say plus x minus 3. Okay? And that's essentially what we're going to do. We're just going to factor this like a quadratic expression in terms of x. So instead of x, we're just going to use tangent as our value. So just like what we would do here, we would multiply a times c. A times c in this value in this problem is going to be 4 times negative 3. And that's going to be negative 12. And we need to figure out values that multiply to negative 12 but add to positive 1. And that would be positive 4 and negative 3. Okay, so we're going to rewrite this as 4 tan squared theta. Actually, let me write this so we have some more room. I'll write on the bottom. So we'll have 4 tan squared theta plus 4 tan theta minus 3 tan theta minus 3. And then we're just going to factor like this. So we'll have 4. So factor by grouping, 4 tan squared plus 4 tan. We can factor out a 4 tan theta. And we'll just be left with tan theta plus 1. And then from these two terms, negative 3 tan theta minus 3, we would be able to factor out a negative 3 times tan theta plus 1. Okay, so our two terms that are like that we can kind of pull out, we're going to pull out tan theta plus 1. And then we can group together the other two terms for tan theta minus 3. And that's going to be our final answer for this expression here. So we have our two binomial terms, tan theta plus 1 times 4 tan theta minus 3. All right. And then lastly, we're going to take a look at example 3 here. We have cosecant squared x minus cotan x minus 3. So immediately you're looking at it, you're like, well, we have our expression is in terms of two different variables. So that's our first task. We need to rewrite this so it's all just in terms of one variable. So we're going to get everything in terms of cotan of x. So cosecant squared, if we look at our reference sheet, cosecant squared of x, we can rewrite that as 1 plus cotan squared. So it's going to be 1 plus cotan squared x. And then we'll keep the other terms the same. Minus cotan x minus 3. All right, and we can combine the 1 minus 3, so we'll have cotan squared x minus cotan x, and then minus 2. All right. And then from here, it's pretty similar to, it's just like factoring like a quadratic expression, both of these terms. That term, the 4 tan squared plus tan minus 3, and this cotan squared minus cotan x minus 2. So we're trying to figure out what values would, when we do a times c for this problem, our coefficient a is technically 1 because it's 1 cotan squared times our c value is negative 2. So it's values that multiply to negative 2 but add to negative 1. So it'll be negative 2 and positive 1. And because our coefficient is 1, we can just go straight to our final factored form we don't need to do the factor by grouping. So it's just going to be cotan x minus 2 times cotan x plus 1. All right. So these are just a few examples of how we can use the factoring and our trig identities in conjunction with one another to rewrite these trig expressions.